Hey guys, so in this video I'm going to talk about Entity Framework Core and how in some situations you can cause deadlock on your SQL Server database if you're not careful enough of what you're doing. I have a sample code here. It's just a simple console application. So here we have a simple DB context. It has two tables, blogs and posts. This is my connection string to my local SQL server. My blog has an ID and a URL and then lists of posts. The post has an ID, title, content, and connected back to the blog post. So a blog can have multiple posts. So here's the SQL server. We have the blogs table and posts. So let's look at the code in program. So here I'm creating a new blog, saving it, and then updating the URL, and then adding a post, and then saving it. So let's run this. So here we see inserting a new blog, updating the blog, and adding a post. So let's check that in our tables, blogs. So we have our first entry here, posts, we have another post here. So what happens if you have some other code here that throws an exception? Let's say throw new exception. Yes. Well, you say that's simple enough. The blog will be created, but the posts and the URL won't be updated. Is it true? Yeah, we have an unhandled exception, although the blog was posted. So let's see here. Yep, we have a new blog, but no new posts. That's expected. But let's say, hey, I want to have a requirement where if the URL is not updated and the post is not added, I don't want a blog to be added. Simple enough. You can move this to the end. So in Entity Framework, whenever you have save changes, all the aggregate changes are all saved together in one transaction. So if I execute this code, we shouldn't have anything saved because this throw exception will prevent that. So let's try it. So here we have the comment says inserting a new block, but there's a followed by an unhandled exception. We shouldn't have any new blog posts. We had two, we still have two. Okay. What if you have some constraints that you can't do that? You still want to have save changes here, but you still want to maintain everything committed in one transaction. Well, Entity Framework provides you with this, which is you can wrap your code inside a transaction. So you do db.database.begin transaction, and then at the end of the code you do transaction.commit. That should work, right? So now we have a save changes here, but then we have an exception. So when this exception is thrown, the transaction should automatically be rolled back because notice the using. So using wraps everything in a try catch, and if there's an exception, the transaction is automatically rolled back. So let's try this. So it says inserting a new block on handled exception. So we should not expect to have a new block inserted because although we have a save changes here, the whole thing is in a transaction. So we should expect the transaction to be rolled back. So let's see here. Yep, there's nothing here. And just to prove that, let me uncomment this and try running it. It should work. It should add both the blog and the post. Inserting a blog and updating the blog. Let's see. Yep, there's a new blog, and then there is the posts. Let's complicate it a little further. Let's say in your application, this part is in a different class or in a different function, and that class has its own DB context. So it uses its own DB context. So let's add that here. So now we have DB2, and let's say you're adding a new block, you're passing the ID to this function. So now you're gonna read it back and then update it. So what you do is var log equals db2 dot find with the new blog dot id blog id. So now you have your it should be db2 blogs dot find. So now you have the blog. So now you're gonna update it. So this is a big problem because now you have a one DB context. It starts its own transaction, but then inside the transaction you're starting a new DB context that's not aware of the transaction from the first DB context, and is trying to read the same entry in the database. So this will cause a deadlock. So first let me show you, and then I can explain why there's a deadlock. So here, boom, boom, we're inserting a new blog post. Now we're trying to read it. What happens here? It's blocked. Nothing happens. If I go to the DDB and do a select block, everything is blocked. Even the database is blocked. Like I'm doing in SQL management, I cannot. So there's a deadlock in the database. So eventually this will, usually there's a 30-second timeout. Eventually this will time out. So here the transaction will be rolled back, so the lock will be released. So now here you see, now it's responsive again because there is no more deadlock. So what happened? So the way this begin transaction is implemented on the SQL server is they create a lock depending on what you're doing inside the transaction. So here we're inserting a new blog post. So this transaction will create a lock on a table entry. It doesn't place a lock on the whole table. It places a lock on that particular row in the table. So when this second DB context tries to read that row in the table, it's locked. It cannot access it because that belongs to this DB context. So how can you solve it? Okay, actually before I show you how to fix it, I want to demonstrate the point that the lock is not on the whole table. It's only on this single row in the table. So let's try to run this again. So here we create a context, we create the transaction, and then we insert a new block. Once we inserted the new block, there's a lock on this new entry. So let's go and run select on the whole block. This is locked because you're selecting everything, including that row that's locked. So if I run another query that if I now do another select, it's still locked. But if I do where log ID is equal, I think the first one, this should work because this row is not locked. But if you remove this condition, you're querying the whole table. That's why which includes the row that's locked. So now we have to wait for this transaction to finish. So this shows you that whenever you start this transaction, it's going to place a lock on a row, if depending on what you're doing. So you should be very careful of what you put inside the transaction. It should be quick and it doesn't affect other clients reading the database. So here we're blocked, so we're gonna wait for the connection to timeout so the transaction is rolled back. The default timeout is 30 seconds. So if you manually change your default timeout longer, so you could cause longer locks, longer deadlocks on your DB. So now we're good to go. So how do you fix this? Well, the first one I mentioned, use the same context everywhere. So don't create a new context. The second way is to pass the transaction to the second DB context. So here, what you do is db2 dot use transaction db2 dot database use. You have to do some using statements. So here my using statements, and then so now you're passing this transaction to the second DB context. So this will give this second DB context the same lock that this one has, so it can read it. Before it didn't have that lock, so it was waiting for this DB context to finish doing what it's doing, it's committing, but since it is in the way, there's a deadlock. So now it has the lock, it can read the entry, but there's another step actually. They need to share both the same transaction and the same connection. So I'm gonna change my DB context to have a constructor that takes so here I'm passing the connection string as a string. I'm gonna change it to pass the connection in the constructor, so I can, every time I create a new DB context, they have the same connection. So here I'm gonna do create a connection and then pass the connection to both DB contexts. So now this one should work. It should not have a deadlock. So let's try it. Creating a new block. Now the second context is using the same transaction. It's reading the block without a problem, updating and saving, and then committing. Boom. Let's see. We should have, yes, we have a new entry. Where is the posts? Where is the post? Let's try. Did we? Oh, so this one should be DB2. There was a DB2 save changes because this portion, yeah, because that one already saved it. We didn't put the posts. We put the post on DB2, but we saved it on DB1. So this should work. So see, post, yep. I ran it twice because I hit F5. So this is the way to fix it. Obviously, the first one was using the same connection, the same DB context. Second fix is to share the transaction between the two. There's a third one if you don't want to share the transaction. Let's say you don't want this. What you can do is start this in a separate thread. So you could do task dot run, and then put this whole thing in it. And of course you should wait because you don't want to fire and forget. So that task equal task dot run, and then at the end you can wait for it. You should await it, but this is a console application. You can call wait here. So this shouldn't cause a deadlock even though I'm not passing the transaction to it. Why would you say that? Because let's say this runs in a separate thread, it will wait for this to finish its work. So once you go here, the code will bypass it to finish its work and then commit it. So there won't be deadlock in this situation. So let's try it. So we add a new blog post, we save it, we commit it, and now we're trying to read it. This read will block until the transaction is committed because there's someone is have a lock on it. So this will wait. So since the transaction has already committed because it ran on a separate thread, now this should work fine. It's trying to wait here, but it should have executed. Yeah, see, it saves it now. So now we should see, yep, blog is saved, the post is saved. So yeah, that's basically, you should be very careful when you're using begin transaction. Whatever you put inside the begin and commit transaction should be minimal, and preferably you should use the same DB context, but if you have to use a separate DB context, you should share the transaction to that second DB context, or at least run it in a separate thread so it doesn't cause deadlock on the DB side. That's all. Thank you.